Hi, and welcome back to the talk. I'm Shruti, and this talk is about cross-lingual entity linking for low-resource languages. In the previous two parts of the talk, we discussed candidate retrieval methods for low-resource entity linking that result in significant improvement over previous techniques. In this final part of the talk, we focus on a different but closely related task, named entity recognition. I will discuss the method to use pivoting-based candidate retrieval to improve low-resource named entity recognition performance. First, let's define the task. The objective is to identify named entities in text along with their types, such as person, location, or organization. The input to an entity recognition system is a sentence of text, and the output is a sequence of tags, one for each token in the sentence, that identifies whether the token is a named entity or not. Performance is usually measured with F1 score, and state-of-the-art methods on English datasets have F1 scores of over 93%. On the other hand, the performance on low-resource languages is usually much worse. One reason for this is that the amount of annotated data available for training models is much smaller in these languages than in English. So in this talk, we're going to present a method that investigates whether information from English knowledge bases can be used as supplemental information to improve the entity recognition performance in low-resource scenarios. As you've probably guessed, we're going to use the pivoting-based candidate retrieval model that we discussed earlier in the talk to get this information from the knowledge base. Before we jump into how to do that, I will first introduce how handcrafted features have been used in named entity recognition systems in the past, which we draw inspiration from for our method. So before the widespread adoption of neural networks in natural language processing systems, named entity recognition models use linguistic features such as syntactic and lexical features to improve performance. It has also been shown that integrating these handcrafted features with neural models is useful and leads to better performance on English text. Of specific interest to us here are the linguistic features created based on gazetteers. So gazetteers are large lists of entities that are manually collated from various sources. Gazetteer features for named entity recognition systems are constructed by looking up the input string in the gazetteer and then forming binary valued features based on whether the string is found in the gazetteer, as well as the match type like location or organization. The features are usually constructed at the word level in the input sentence. While using additional information from gazetteer features, it does have the potential to benefit named entity recognition for low-resource languages. There are several challenges. Specifically, existing gazetteers in low-resource languages are very limited in their coverage. For instance, Wikipedia, which is an often used source for collecting gazetteers, has over 2 million entities in English, but far fewer in low-resource languages like Kinyarwanda, Oromo, and Tigrinya. Expanding gazetteers is both time-consuming and expensive, and additionally, finding enough annotators is difficult for some low-resource languages. As an alternative to the standard binary-valued gazetteer features, we present soft gazetteers. These features do not rely on large entity lists in the target language. Instead, they are constructed using information available in large English knowledge bases such as Wikipedia. We use the pivot-based entity linking method discussed earlier in the talk, which was specifically designed for low-resource languages. We use this method to extract the knowledge base information and create the soft gazetteer features. In the process, I will explain next. So as we saw earlier, entity linking systems typically score knowledge base entries based on its similarity to the input. So given an input sentence for named entity recognition, we first split the sentence into spans based on tokens. In our case, we use up to 3 words per span. For each span in the sentence, we use the entity linking method to retrieve a list of the top scoring knowledge base entries. The scores are then used to create soft gazetteer features for each word in the span. For example, consider a feature that represents the knowledge base entry with the highest similarity score to the input span. Given a sentence such as this one in the low resource language Kinyarwanda, we use entity linking to obtain a list of knowledge base entries with their score and the entity type such as location, person, or organization, which is typically easily available from the knowledge base itself. So using these scores that come from the candidate retrieval method, we create soft gazetteers for the span. These features are continuous valued and are based on the entity type from the knowledge base entry. So the feature vector for the span is then applied to each word in the span, as shown in the figure. They are applied differently depending on whether the word is the first word in the span or not. This reflects the BIO tagging scheme that's commonly used for name entity labeling, where words tagged with the B tag represent the beginning of an entity, and those tagged with an I tag represent inner words in the entity. Similar to features representing the top scoring entity, we also add features that represent the top 3 candidate scores, the top 3 typewise counts, the top 30 typewise counts, and the margins between the top 4 candidates. The vectors for each type of feature are computed and then concatenated to form the final soft gazetteer features for each word. We use a BILSTM CRF architecture as the named entity recognition model because this is commonly used in several state-of-the-art systems. The BILSTM encodes the input sentence, and the CRF makes a globally normalized prediction of tags over the sequence. The soft gazetteer features are incorporated in 2 ways. First, they are concatenated to the character and word embeddings at each token of the input text. This concatenated representation is then used as input to the BILSTM. Second, they are used as input features to the CRF. We also add an autoencoder to reconstruct the features from the hidden states of the BILSTM. The autoencoder reconstruction loss is added to the training objective to encourage the BILSTM to retain information from the soft gazetteer features. We conduct experiments on named entity recognition on 4 low resource languages, Kinyarwanda, Oromo, Sinhala, and Tigrinya. The annotated data sets for named entity recognition in these languages are very low resourced, merely 4 to 13% of the size of the standard Connell 2003 English data set that's used to evaluate most state-of-the-art systems. We compare the soft gazetteer method to 2 baselines. The first is the BILSTM CRF model that doesn't use any gazetteer features. The average F1 score over the 4 languages in our data set is represented here in the graph. We also compare to the existing method of creating binary valued features with a string lookup in the gazetteer. We create the gazetteer from the small number of Wikipedia and a small number of entities available in the Wikipedias of these languages and create the binary valued features here. This method does improve the F1 score over the model that uses no features at all. Finally, we see that creating soft gazetteer features from the pivot-based entity linking methods candidates and incorporating them into the named entity recognition model results in the best overall performance. Next, we analyze what types of named entities actually benefit from the addition of soft gazetteer features. We compare the recall over these entity types between the baseline and the soft gazetteer method. So first, we expect that entities which have a valid corresponding entry in the knowledge base will benefit from the additional information obtained through entity linking. If an entity does not have a valid link in English Wikipedia, it is considered unlinkable in the current setup and likely wouldn't get any extra information through the soft gazetteer features. We also look at named entity mentions in the test set that are unseen during training, which might also leverage the additional features for improved performance. In the figure, we see the recall for both these types of entities. And for both cases averaged over the 4 languages in our data set, the soft gazetteer features do indeed improve recall over the baseline. So to summarize, the method creates soft gazetteer features for the named entity recognition task, and these features do not rely on high coverage entity lists. The features improve performance over existing systems and experiments on 4 low resource languages. In terms of future directions, it would be interesting to explore more sophisticated feature design, as well as combining knowledge-based entries from different entity linking methods, such as the translation-based method. So overall, in this talk, we discussed methods for cross-lingual entity linking in low resource languages. The methods we presented for candidate retrieval do not require bilingual resources in the source language. We also presented a systematic analysis of the errors made by the model, and using this information to make informed modeling and data improvements to the model. Finally, we used the improved candidate retrieval method to supplement low resource named entity recognition models. So that concludes the talk. Thank you so much for attending. The corresponding papers for the methods that I discussed today have more experiments and analysis if you're interested to take a look. Again, thank you so much for attending, and feel free to send me an email if you have any questions or suggestions.